Hi everyone, and welcome to Noisebusters. For those of you that are new to the show, in a nutshell, myself and George started the show to basically have an informal way to create awareness for careers of people that are in the acoustics industry or have left it or whatever, with the main aim to let people know it is an option as a career and some stories around the backgrounds of people that have been involved there. We also wanted to provide perspectives from those people in the industry on a whole range of topics, so not just their career, but any kind of insight. And we touch on some news articles and things in the industry to kind of try and keep up to date with those things. If you ever have any ideas on topics or people to get on the show, if you're interested or know someone that should be on, please let us know via our email at noisebustersdb@gmail.com. You'll see it in the link in the description on YouTube and everywhere else that we appear. You can watch the show on YouTube, which you may be doing here, or find us on your favorite podcast player for those who are busy folk that want to go jog and do stupid things like that and listen to us, or understandably don't want to look at us all the time. I get that completely. Let's check in with George. How are you doing, mate? How's it going?
I'm good. I was looking before. It's actually been 5 months since we last did this.
It's quite appalling.
It is. Well, we did meet up at Christmas. We met up in the rain in Preston, was it?
Yeah, Preston, UK. Yeah, we met for like an hour and went dogging. Is it the phrase? Took George's dog for a walk.
It was about enough, an hour, I think, and then we sent you back to Canada, I think.
Yeah, good riddance and all that stuff.
Yeah.
The last person we had on was Rob Galt from Eminence, which was an interesting episode. It was good to get his input and experience from that. And so, yeah, we're trying to get more guests on and get this going again. I think, George, that's the idea, isn't it?
Yeah, it was another late night for me getting on these calls. An early start for you guys.
Yeah, 2 p.m. over here. So today's guest grew up in Brooklyn, New York. He has a chemistry education background, but started working with waves, if you like, as a diffraction physicist at the NRL in the US. And he was first interested in acoustics when he was looking to build a private recording studio for himself and just had no idea what acoustics was and what the hell should I even do. So a few years later, he formed RPG Diffusor Systems, which we'll find a little bit more about in this episode. In 2007, he also founded the Chesapeake Acoustics Research Institute, I'm probably pronouncing that wrong, but to provide education, mentoring, and private acoustical consulting in select projects. He even found the time to write the book that I had at university, the one that he did with Trevor Cox on Acoustic Absorbers and Diffusers, Theory, Design, and Application, which was kind of the Bible, if you like, for want of a better word, around that topic, and contributed to many chapters in the Master Handbook of Acoustics, a couple of notable mentions there, but he's been involved in so many different areas of acoustics and definitely one of the big names in the field. So we're really excited to welcome him on the show, and he's taking the time to do that. So today we are very pleased to welcome Peter D. Antonio to the show. So hi, Peter. How you doing?
Hi, how are you guys? Nice to be here. Thanks for the invitation.
Likewise, thanks for coming and joining the show. I hinted it in your intro, but you were looking to build, a recording studio, and that was your first kind of taste of what you would define as acoustics nowadays. What was that like when you were without any kind of guidance, and what were your thoughts at that time, I guess?
Well, that's interesting. Well, like many acousticians, I'm a musician, and I found my way to acoustics through a very circuitous path because my formal education, as you mentioned, was in chemistry and physics. After graduating from the Polytechnic Institute of Brooklyn in 1967, where I studied infrared spectroscopy and crystallography, I began my scientific career at the Naval Research Laboratory under the guidance of Nobel laureate Dr. Jerome Karl. And we were using X-ray, electron, and neutron diffraction techniques, as well as electron microscopy and atomic force microscopy. But as you mentioned, in 1972, I returned to my love of music and built this private recording studio. Well, as a scientist at the time, I went to the scientific literature, and I could find no mention of how to design a studio. So I went about and studied sound isolation techniques, and because at the time, the group that I was recording with was getting louder and louder. I had a young son, with the bedroom above us. So I decided to build an isolated room in which we could record original music. And that went on for some time. But at lunch one day at the lab, I came across an article in Physics Today in October of 1980 by Manfred Schroeder, where he was describing a new device, a reflection phase grading diffuser, which he was interested in using in concert halls. At the time, I had no interest in acoustics whatsoever, but I found the topic really intriguing because these devices were essentially two-dimensional repeating structures. And in our lab, we were studying three-dimensional crystals, the structure of three-dimensional crystals using all of these different diffraction techniques. So I was very familiar with the mathematics, and so I began researching these devices, and I became more intrigued the more I started studying them, and decided to redesign the studio and convert it into a professional recording studio using these diffusers, and upgraded the studio. At the time, we were using 2-track recorders. We hot-rodded one of the original 2-track recorders to do sound on sound, so we could do multiple tracks, and we later evolved to a Revox recorder and felt like we were really getting into the big time. It was a half-track recorder that had built-in sound on sound. And so after reading this article by Manfred Schroeder, I redesigned the studio and found that there was a lot of interest in these surfaces. And so I began furthering my research by modeling them, because I had all of the modeling background, and also testing them, which had never been done. And I started, that was the very early stages of room analyzers. I became acquainted with a company called SynodCon, with which I was doing a lot of teaching, and they introduced me to a very talented person called Richard Heiser, who brought time delay spectrometry to the general public. And so I obtained one of his devices that was manufactured by Crown, called the TEF Analyzer, and began modeling and measuring these diffusers, and also measuring the room after the installation of these diffusers. And so this is really where my two worlds of diffraction physics and music converged. And so seeing the need and the potential for these devices, I basically decided to form RPG Diffusor Systems in December of 1983. This really was a personal interest at the time, but the interest in the products just continued to grow and grow. We started in recording studios, then eventually evolved to home theaters, worship spaces, performance spaces, and eventually all of architectural acoustics. And so I retired from the Naval Research Laboratory in 1996. So between 1983 and 1996, with my diffraction research career in full swing, running RPG and underground sound recording studios with international promotional travel, essentially for 13 years, I did not sleep. I mean, it was a very heady time. It was very exciting. That's what happened. So,
just for those that don't, understand RPGs and diffuser systems, what do you have like a basic kind of summary of what they are and why that tech was so, revolutionary at the time?
Well, at the time, recording studios were basically designed with a reflective front and a essentially black hole in the rear. The idea was the sound would come to you, you would hear it, and then it would disappear. And what became very apparent with the use of this TEF analyzer was that the reflections from the reflective sidewalls were combining with the direct sound, causing interference. And so a creative person named Don Davis and his wife Carolyn came up with an idea for a live end, dead end type of control, basically turning the recording studio around. And the design consisted of absorbing those interfering reflections in the front of the room and then diffusing the sound in the rear, or just doing something with it in the rear to creatively utilize it. Well, at the time when I became acquainted with them and began sharing my research, it occurred to me that I now knew how to diffuse the sound in the rear of the room. And so that's why it became, or the use of diffusion became so critically important, because the people that I met through Synod Con were international studio designers. They wanted to move into this type of a control room design. And so I developed a standard for control room design in which I had created a reflection-free zone, meaning that the listener was surrounded by a reflection-free volume in which he or she could perceive the direct sound from the monitors without any disturbance from interfering reflections, and perceive a very accurate sound stage. And then as the sound traveled to the back of the room and the sound hit the diffusers, it was uniformly scattered. And I didn't call it this at the time, but we basically had created passive surround sound, because when the sound was diffused from the rear and was scattered in all directions, it bounced off the reflective sidewalls and came to the listener from the sides. And there was a significant amount of research in the scientific literature by Manfred Schroeder principally, where they determined that our sense of envelopment in sound, or a sense of immersion in sound, comes from these interfering these lateral reflections, which create a sense of envelopment in the sound. So the more people that I met, the more people wanted to use these diffusers. And so I had to set up a company and a manufacturing capability. I had never been a manufacturer, so I started out by purchasing some saws and routers and what have you, and leased a workspace, a very small factory at the time, and just started manufacturing these devices 24/7. We literally could not manufacture them fast enough. A lot of our initial business was in Europe. I had met a very prominent designer named Neil Grant at one of the SynodCon meetings, and that was a pretty busy day, pretty busy time in the UK. And he was involved in many recording studios, and we worked together and became friends. We eventually did Peter Gabriel's recording studio at Real World in Bath. Met some additional people who had work in China. We started doing international projects in Asia, and eventually the business came back to the States, and we became involved with recording studios here in the States. I met John Sturek many years ago, and we basically collaborated on all of the WSDG designs. And in fact, we're still collaborating, as I'll talk about. So that's why the diffusers were so interesting and to designers. And RPG essentially just continued to grow and grow and grow. And I eventually sold RPG in 2017.
Yeah, it's great. So with the markets kind of growing initially in Europe and then maybe China and elsewhere, what do you think was the reason that those markets were more hot for the kind of diffusion concept compared to like North America?
Well, I think it was a question of just that is where we began, because the first designers that I met were in England, and so it started there. And then, as we began to publicize the results, designers in the United States like Russ Berger and John Sturek and pretty much all of the US-based designers that were interested in using this reflection-free zone, diffuse zone idea, became clients as well. And it wasn't that long after we did the projects in Europe, because as we began to advertise and present this data, I was used to making a lot of presentations because of my scientific career. So I used to make presentations at all of the Audio Engineering Society meetings and all of the Synod Con meetings around the country. There were a traveling group that basically had seminars in different cities all around the country, and I was part of all of those seminars for a while. And they basically introduced me to the world of acoustics because, like I said, I had no formal training in acoustics. So it just continued to grow over here, and I have to say, most of the people that I met, we're still friends and we still collaborate. In fact, we just had a session in Nashville, an acoustical society meeting, where I invited Neil Grant to come because we had worked on several studios in Nashville together, Reba McEntire's studio, and I collaborated with George Massenberg on a very popular studio called Blackbird, which was done 17 years ago. And so we had a seminar there, and we designed a very, very special sound diffuser that was 4 feet deep. And the diffuser wrapped around the entire room. There are 180,000 woodblock heights, as well as different woodblock and other diffuser in the ceiling. So there was an acoustical society session in Nashville, and we had one of the sessions right in the studio, which is now a very popular destination for Dolby Surround. It's funny because it was originally designed at the beginning of people's interest in immersion of sound, like 5.1, 7.1, 7.2. And now it's there's 16 speakers in the room, 9.6.1. And I don't know if it could get any more complicated. But Dolby Atmos is very popular now, and it's the type of room that we are looking at optimizing.
I don't want to skip over the fact that you were a student in New York in the 60s. What was that like? I mean, there's so much going on. Into 1967. You've got all the Vietnam War and the riots are going on, but also there's a lot going on in music. And I could tell that you are a musician at heart. What was it like, and what kind of things were inspiring you at that time?
That's an interesting question, because when I graduated with my PhD and I moved from New York to Maryland, which is where I am currently still living, and in 1968 there were a series of riots, and the part of Washington D.C. on 14th Street corridor were burned down. It was a very tenuous time, just in terms of the political and the social environment. But it was also in the early 60s when I started graduate school. You could imagine being a musician and not being inspired by the Beatles, right? So I mean, there were bands playing in pretty much every venue that existed. I mean, you did not have to be a very good band. Every restaurant, every bar, every venue you can imagine had a band. And so, we played quite a bit, and I played through graduate school at summer resorts. And when I moved down to Maryland, I had just started a scientific career, and the laboratory, as you can imagine, consisted of very, very, very smart and intelligent people. So it was a challenge. It was a difficult challenge because I was working in an area that I had not really gotten a degree in. I was designing electronic measurement equipment, electron diffraction apparatuses. So I had to learn a whole new career. It's just interesting that It is, I don't know how rare it is, but it seems rare that people have a background in acoustics and go into the field of acoustics because, I mean, I started in infrared spectroscopy and got a degree, and I never did any infrared spectroscopy the rest of my life. However, I did some crystallography, but it's interesting that both infrared spectroscopy and crystallography both use a diffraction grating. Okay, a diffraction grating is just a device that separates a polychromatic wave into individual frequencies. That's exactly what the work that Manfred Schroeder introduced me to, because these reflection phase grating diffusers just diffuse sound. They're just gratings. And so while I never realized it at the time, my formal education was like infinitely useful in my acoustics career. I didn't have to really do any acoustics training. It all relied on my previous education. But it was an interesting time. When I finally got back to music in 1972, and so it had been a little while since I moved to Washington, D.C. It was 4 years or so, and then I got back into music and got into it in a vengeance, but started RPG and basically didn't do any music for quite some time until we finished the studio. And I mean, everything in the studio was hand built, hand wired. I came across a very talented electronic engineer in Maryland who was designing custom consoles. At that time, you didn't go to Mix Magazine and pick amongst 20 consoles that you could purchase. There were no commercial consoles available. And his name was Neil Muncy, passed a while ago. He designed a set of modules using the API op amps. And we used those modules and wired the whole console together with a patch bay at the time where you could patch into different stages in the recording chain. So I did a lot of engineering in underground sound once it became a commercial venture. Met a lot of interesting people, spent a lot of late hours doing recording sessions and going to work at the lab, bleary-eyed some days.
What was it like when you kind of get people in that environment with diffusion and it was so different and revolutionary? I guess engineers and also just the general public, did they notice a difference? What was the kind of perception from your experience?
It was a very dramatic difference. What was happening then is when I started underground sound, project studios were beginning to evolve. And there was a distinct difference between a project studio and a professional recording studio. Project studios did not have very good acoustical design. They had equipment. The equipment eventually evolved as digital technology became more pervasive, but they always lacked acoustical design. The professional recording studio had both professional gear and good acoustic design, quote unquote good acoustic design. Well, when we introduced the diffusers to the industry, the project studios essentially gained a step on the professional studios because now they were able to incorporate this design that we came up with the reflection-free zone and the diffuse rear wall. So they became very competitive with professional studios, and that has really progressed to the present time, where many of the recordings these days are done on workstations. Take Billie Eilish, in her bedroom, but it's amazing how professional recording studios still persist. They're still important because much of the work that's done in private project studios gets mixed in a professional recording studio. I can't tell you how many professional recording studios we still do. Because of the success of the diffusers, a whole diffusion industry was created. And if you can go online and type the word diffuser, and you can trip over all of the companies that make quote unquote sound diffusers. I don't know how effective they are, but there are a lot of products in the marketplace, which I feel very proud of. So I think that's really the way the whole recording industry evolved from, the basement studio to a very competent private studio with still a need for a professional studio for mix down. And of course, still the mastering labs. We worked a lot in the early days with Bob Ludwig at his mastering facility. They still maintain a very high quality in terms of acoustical performance. And the difference, I think, was the fact that you had the soundstage now with the reflection-free zone. You still had a very accurate soundstage so that you could place your images. But now you're in an immersive environment so that when you added some signal processing like equalization or reverberation or what have you, you could perceive that signal processing the way it would be perceived in another venue, another room with a different acoustic. There are some, the RFZ is not the only design for recording studios. There are many that are basically anechoic. They're just a very dry design. And to my personal taste, I never liked that because I can never evaluate the value of the signal processing in that environment without any ambiance.
Mm-hmm.
So,
especially things like reverb, etc.
Yeah, and so there are many approaches. I've come to the conclusion after however many years, which we won't talk about, that it's really the music that is important. I mean, just think of the early Beatle records, but you had the drums on one on the right side and the rest of the band on the other. It was the music that made it, and it's still the music that makes it. Yes, it's great to be able to perceive the music and enjoy it in a very interesting environment. That's why the home, when we evolved from recording studios to home theaters, that was a really big change because home theaters typically did not have much acoustical design. And with the introduction of dinosaur footprints, and other interesting acoustical surround sound effects, the design of home theaters became very popular. In fact, it became our entire business for several years, which we partnered with Mark Levinson at a company called Cello, and basically we're working on home theaters all around the world, really all around the world. And there is a man called Mark Levinson. I know there are amplifiers that have his name as part of them, but he designed those original amplifiers with his team. So it was an interesting evolution through the years.
It's really good when you speak very fondly of the Beatles. I don't know whether you're saying that just because I'm from Liverpool, but I live very close to Penny Lane, and for me, I could listen to the Beatles anywhere and it still sounds amazing. The only place I'd say I think it's terrible, and I don't know why they do this, but there's the ferry across the Mersey, and they play the Beatles on there, and it sounds terrible. And they play Ferry Across the Mersey, and then they play You'll Never Walk Alone, and then they play Ferry Across the Mersey again, and then you're at the other side. And then
Jerry and the Pacemaker.
Fantastic.
But we haven't talked about my relationship with Trevor yet, but I used to visit him quite often in Manchester, and I took the train over to Liverpool one day and got completely lost in the Beatle Museum. I mean, it was the end of the day, and I had to catch the train, and I don't think I even had lunch that day.
Oh, Peter, you're welcome in anytime. You obviously it's been very accomplished technically. You're obviously an accomplished businessman as well. Have you got any stories of particularly difficult clients, given this is a relatively subjective field? It's very difficult sometimes, I'm guessing, to gauge what is a success and what isn't on the behalf of somebody else.
I can't say I really had trouble with clients much. I didn't really deal with clients. I dealt with the designers. All the designers basically were my friends, and the biggest challenge was growing RPG at a fast enough rate to keep up with the timeline of the orders. most timelines are very short. And, when you're really busy and you're growing, not only did I have to grow the business, but I had to grow the factory, I had to grow the employees. And at the end, we started with one 10 by 40 foot bay. And when I sold RPG, and I think we had about 10 or 15 of those bays full of all kinds of equipment and what have you. So we did have one project in Istanbul, which was it was interesting and it was very complicated. We designed, this was for the Iş Bank, which was sort of like the Bank of America or the Bank of England in Turkey. And they had an auditorium in which they wanted variable acoustics. So I designed a triangle, which in the theater they call a periactoid. And we had a reflection on one side, absorption on the other, and diffusion on the third. And I partnered with a theater company to automate this under computer control. And so these devices lined the side walls of the Iş Bank. And when they were talking, when they had a speech event where the intelligibility needed to be high, we used an absorbing surface, and where they had music, we turned to the diffusing surface. And that project had some mechanical problems with the automation. So I don't have very good memories of that. There were 2 trips to Istanbul, which I wish were sightseeing visits, but they were somewhat sightseeing, but they were all, control problems.
Eye-opening, I guess, is the word.
Yeah, very eye-opening.
That's fun. So, Peter, just to reflect a little bit on specific designs, I know that historically, I think the QRD diffuser was one of the more synonymous ones that people think about. The shape, you see people on YouTube like trying to build them out of, one by one pieces of wood and whatever. But I know that there's obviously the diffuser science and the design has changed quite a lot over the years to even some more of these kind of convex, kind of curved shapes. And
yes,
do you want to debunk a few myths or talk a little bit around the differences between those and how we've come from, say, that design to more of the more modern ones?
Sure. In fact, to kind of answer that question, Dan, I recently started a LinkedIn page, hashtag Dr. Peter D'Antonio, in which I go through that whole evolution. But to simply state it, the original quadratic residue diffuser, which was the initial product, even though we had primitive root diffusers, the QRD, as we called it, became the most prevalent. Like any mechanical device, it has its bandwidth. It's like a loudspeaker. The QRD was essentially a mid-range driver. And so the first thing that we wanted to do was to broaden the bandwidth. And so we patented a device called a fractal diffuser, or a diffractal. In the wells of the QRD, which are the different depth wells, we inserted a high frequency diffuser. Okay, so we essentially added a tweeter to the loudspeaker. And it was interesting, in going to a meeting at Penn State one year, I met Manfred Schroeder at the airport, and we flew to the meeting at the University of Pennsylvania together. And I told him about this diffractal, and he was really intrigued by it. And it was a great compliment, because he paused the publishing of his book to include a discussion of the diffractal. That was a very heady moment. So once we increased the bandwidth, the next thing that we realized, that without going into too much detail, these diffusers are operable up to a certain frequency, and then they become a reflector, and then they become a diffuser, and then they become a reflector. And so to get around that problem, we had to get away from using these, what I call quantized well depths, where the well depths were designed by number theory. So number theory basically is a sequence of numbers. The QRD had a sequence of 14222410, the relative depths of the wells. And so we had to develop a way, and this all came about through my interaction with Trevor, a way in creating optimized diffusers, which did not have an integer relationship between the well depths. So you could have a 1, you could have a 2.3, a 4.8. Mm-hmm. And so we got around that. That's called the flat plate frequency. Because these devices were being used in all forms of architectural acoustics, there was really a request for surfaces that did not have this aesthetic of wells, divided wells, mm-hmm. or block heights. And so that's when I started to work more collaboratively with Trevor, because we developed a program called the Shape Optimizer, which was a boundary element program, which allowed us to design the shape of curvilinear surfaces, sine waves of one type or another. And we developed a set of software tools in which the architectural acoustic team would present us with a shape motif, let's just say a sine wave. And we would put that into the program. We would parameterize that shape, put it into the program, and optimize it. So not all the heights of the sine wave would be the same. Some would be higher, some would be lower. Some of the depths would be higher, some would be lower. But we would maintain the motif that the architect had in mind. And that became a very popular design, and it evolved into what we call a whole line of products called waveform. And these are all these curvilinear shapes, both in one direction and in two directions. So the two-dimensional waveform would look like the contour plots on the head of a drum. There'd be peaks and valleys in two directions. And so many of the products that you see online are simply replicas of the QRD and replicas of a product we designed early on called the Skyline, which is a series of woodblock heights that were optimized using a primitive root sequence. That was a very popular aesthetic in studios. And so that is probably one of the most copied designs, where people I have no idea what depth sequence they use or height sequence they use. That became very popular. But then we also got involved in designing absorbing surfaces, because low frequency absorbers were sorely needed in these control rooms. And we developed a whole line of products to control the modes in a room. I called it Modex. And those are still very popular. Some of them were membrane designs, some of them were Helmholtz resonators.
Yeah, it's great to see that the evolution of that kind of form, and how architects still have developed, the way that we do acoustics. They can be interesting partners at times. But the thing that was really, the first time I got introduced to yourself was through your book that you did with Trevor, and you've hinted at that relationship a few times. And I'm intrigued as to how that relationship, really got rolling, and why you even thought to develop a book, and what that process was like, really.
It was a very interesting time. I looked up the date. It was 1993. I got a call from one of the editors of the Journal of the Acoustical Society of America, whom I knew, and he asked me to referee a paper by Trevor Cox, who was a recent graduate of Salford, on a boundary element method optimization of profile diffusers. I looked at the paper. I found it incredibly intriguing. It was a real tour de force. And so, to be fair, in the review, I requested additional time from the journal, which they granted. I had never done this before, but I had to write a boundary element method program to verify Trevor's predictions. And I was working at the lab with an an incredible mathematician, and together we wrote this boundary element program, which we had never done before on acoustics. To test the predictions, I had to build an experimental device, which I called a goniometer. That name has persisted over the years. A goniometer was used in my X-ray crystallography work. It's a very accurate device that measures the energy scattered in very specific directions. So we were measuring the scattered energy, and so I thought the name was appropriate. And so this turned out to be the peer review from hell for Trevor, because it took a year, and eventually his paper and my review were published back to back in the journal. But it was a lot of work. I mean, there were no devices to measure the scattering of an acoustical surface, and so this took quite a bit of time. And then eventually, in 1994, a year later, I met him. I met him at as I mentioned earlier, I was traveling around the world giving seminars, and I was speaking at a luncheon for a particular architectural firm, and he was in the audience. And just from the words that I was saying, he approached me at the end and said, "You're the one that reviewed my paper." And so, we obviously had a lot in common, and we became really fast friends, which resulted in many journal publications. The ISO standards for measuring diffusers, and the publication of the 3 editions of the book. But over those years, he actually he was employed by RPG as a consultant, and we basically developed a lot of new techniques, a lot of new designs. The optimization of curved surfaces, the evaluation that diffusers basically become reflectors at some frequency. That was all really new basic research. And we had another really interesting collaboration where we mentored a PhD thesis at Salford for a student named Tristan Hargraves, in which Tristan built the first 3-dimensional goniometer. The goniometer that I built was what we call a ground plane goniometer, where the diffuser, there was an arc of microphones that lay on the ground plane, and then the sound source was further back, and so the sound would hit the diffuser, it would scatter and get picked up by the microphones. And since I did this research in my factory, I did not have an anechoic chamber, so I had to find a way to get rid of the ground plane reflections. So at the time, there were microphones that were being marketed called pressure zone microphones. Mm-hmm. So basically, these microphones sat on the pressure plane, which was the floor. And so we were able to do quite a bit of really interesting diffuser measurements using this ground plane goniometer, which I still have at RPG. Well, it's a new version of it. But what we wanted to do with this thesis was to build a 3-dimensional goniometer. By that I mean the device existed in an anechoic chamber. So you had an anechoic ground plane. The sample was the origin of the device. And then there was a hemispherical arc that rotated around 360 degrees on which the microphones were placed. And then there was another larger hemispherical arc which rotated 360 degrees, in which the source loudspeaker was placed. So with that outer arc, you could place the loudspeaker at any azimuth and elevation position. And by rotating the microphone arc, you could cover the surface of a hemisphere. And so Tristan built this device and measured any number of surfaces, which we compared with my ground plane goniometer. And quite interestingly, the agreement was really quite good for the samples that were validly compared. And then we compared those data with the boundary element prediction and found that it was very accurate. I mean, it became apparent very quickly that one of the things you could really do very, very accurately with the boundary element method was to predict the scattering from a surface. And from that research, we actually developed the standard for measuring the diffusion coefficient, for evaluating the diffusion coefficient. And the way that arose was we looked at these polar patterns. We found a way to look at how uniform those polar responses were, and from that uniformity, we deduced a diffusion coefficient, which was a number from 0 to 1. Another reason why there was continued interest in these surfaces is now because of this research and the previous research that I did with the ground plane goniometer. We now had an additional coefficient that the industry could use. For 100 years, we had an absorption coefficient. Around the time of the RPG Diffusor System, we then added a diffusion coefficient to the mix. And then eventually we added a scattering coefficient to the mix. So you have now a whole array of coefficients that characterize the performance of a scattering surface. And so that was a very rewarding collaboration. Over time, we worked together for many years through the three editions of the book. The last one was in 2007. I forget the year of the first one, but they were several years apart, and there was continued interest, and we continued to grow the size of the book and the topics that were covered. I still periodically go to the third edition when I have to look up something that I've forgotten. And so Trevor, because of his incredible expertise, has moved on to many other areas of interest. I spoke to him the other day on a Zoom call. We still chat and meet up whenever we can at meetings. And I just learned that the university is building a new acoustics building, which is so incredibly rare for acoustics to get that much attention. That's amazing, and I'm really excited for him.
I remember when I went to look around the university, it was like 2000. I can't remember what it was now. 2005, and they were moving from their old campus to where they are now, across the river, and for them to do it again, it was pretty much state of the art anechoic chambers and loads of semi-anechoic chambers and reverberant rooms and stuff, and for them to
rebuild all those chambers and a bunch of other new things that he was telling me about.
But it is it's a globally recognized place. Even moving to North America, where I am now, people still know Salford University is a place to do this stuff, learn this stuff in the labs in particular. So.
We had a lot of fun, and we did a lot of really interesting things. We continue to.
Dan, we were going to ask some questions about people at home, wanting to create their, an optimal listening space themselves, and whether you had any advice for them.
Yes.
Other than your products.
All my products. I think one of the things that, as a scientist, I decided when I first started RPG is that I was literally going to tell everybody what I was doing. Aside from the patents that we had to get as a company just for protection, everything that we did was published. There's a tremendous body of knowledge out there. It's just like when I was a kid trying to learn how to play a song. I couldn't go to YouTube and have somebody say, "Put your finger here," and then move to here. There just wasn't that information available. But nowadays, sound like an old timer. Nowadays, a lot of that information is available, and as I mentioned, the growth of the project studios. There's so much literature out there, and there are so many products, whether they're mine or somebody else's, that it's fairly easy to control a relatively good listening environment. You control the first order reflections, you control the low frequencies, and you put the diffusion on the rear wall. You can upgrade that that environment, but there are just those three basic steps that get you, 80% of the way. And there are a lot of online programs that teach you how to build diffusers, and I still mentor students. So I used to put a lot of time into presenting at schools that had architectural programs, because those students eventually graduated and became acousticians. So it was not completely altruistic, but we were able to educate a lot of students. So in a quick answer to your question, I think there's a lot of information out there and I can't talk about this at the moment because something is in the works, but there will be more online tools available. One of the tools that is available by many companies, or some companies, in which you can go online, measure your room, and then they can create an inverse filter and flatten your frequency response to your room. Now that goes only so far, because you really don't want to be making electronic modifications to your sound system to adjust for acoustical issues. You want to solve acoustical problems with acoustical solutions and electronic problems with electronic solutions. But the more you can do acoustically, the less electronic modification you have to make. And with the incredible advances in speakers and transducers, the last thing you want to do is to modify their electronic footprint to control, an acoustical anomaly in the room, and which is why now acoustics is really, in my mind, as important as it ever was, because our goal is to essentially remove all acoustical distortion in rooms and minimize the amount of what is called, quote unquote, room tuning, which I completely object to, because all that does is modify the anechoic response of the loudspeakers, which now is incredibly good. You have advanced transducer company ATC and PMC. These devices are incredible. Genelec, and there's so many really accurate monitors out there now. So that's why my interest really is taking it to the limit and removing all forms of acoustical distortion.
And you spend so much money on those loudspeaker systems that it just seems strange to then manipulate them electronically.
Exactly. I couldn't agree more, Dan. Especially now with Dolby Atmos. You have 16 speakers in the room.
Yeah.
You have 9 speakers in the horizontal plane, 6 speakers in the ceiling, and one subwoofer.
Wow. I mean, we could go on for forever and ever, I think, on this conversation. We might have to have you back at some point, Peter, to talk about some specific things, because there's a whole host of things I'd like to ask you, but trying to keep it within a reasonable time frame. But
yeah.
What's kind of next for you? What have you been doing most recently? What's inspiring you to keep going with this?
In 2017, when I sold RPG, I still continue as director of research there, but I started a new software company called Ready Acoustics with John Storick, who is a studio designer that I've been friends with for 30 years at WSDG, and PK Pandy, who he has many different credits to his name. He's a studio owner, loudspeaker manufacturer. So we started this company to develop optimization software for critical listening rooms, exactly what I was describing. And so the first output of this new company was a program called Nero, which stands for a non-cuboid iterative room optimizer. in which we combine a finite element method, low frequency optimization below the Schroeder frequency, and image source model and ray tracing above the Schroeder frequency for a full bandwidth room optimization of a critical listening room of any shape. So we're not restricted to cuboid rooms, so it has become very, very popular. In addition, in collaboration with RPG, we developed a novel a virtual goniometer, which I call Virgo, which is a boundary element program, which allows the evaluation. And this part really excites me now because it allows the evaluation of any shape profile that a design team might have from a 3D CAD model. This eliminates the need, to manufacture either a scale model or a full-scale prototype for testing. So the idea is we would get a shape, we would evaluate it in the virtual goniometer, and then if it looks good, that would be fine. The design team can go forward. If it could use a little improvement, we could use the shape optimizer that we developed with Trevor, and provide a shape that satisfies the aesthetic motif in addition to the acoustical goal. And so that is keeping me busy. I continue to research new designs for acoustical surfaces using novel metamaterials, which are all the rage these days, and also aperiodic quasi-crystals, which I find very aesthetic. And as I mentioned earlier, I started this LinkedIn educational page with weekly updates at hashtag Dr. Peter D'Antonio. And that's about where I am at the moment.
Where do you find the time? I mean, you seem to be on the absolute forefront of this field after so many years. I mean, is the plan to just go on and on and on? Are you still so interested in it that you just don't see?
Yeah,
there's too much to do, basically.
Yeah, because I'm not the first one to say this, but the more you know, the more you realize you know. And it's exciting. I'm 81 years old now, and so I still, have a little skip in my step to get up in the morning and go from my bedroom to this room that I'm in now. The traffic is terrific. I mean, there's no traffic.
So Peter, we'd normally at this point just kind of, well, I would say crack a beer, but I've seen George already drinking one.
It's 10:30 here, Dan.
10:30, yeah. So I'm going to crack one, which is I've gone with a stout today.
Oh, dear me.
What you on, Stella?
No, one of mine was a stout. That was earlier on, but and I need a drink as well because I've just seen that my team's lost. But I've gone for Hop the Light Fantastic, which is a Liverpool brewed beer, which sounds nice. But yeah, but it's, what is it, 2:30 for you in the afternoon?
No, it's 3:30 now, so we're in the afternoon, so it's fine.
Dan is 3 hours behind me, I guess, and I'm at 5:30.
2 hours. 2 hours.
2 hours.
Yeah. Taking one for the team, but
and it's Pancake Day today, which I just assumed was an international holiday, but I don't think it is. I had a quick look and I thought surely everybody has Pancake Day, but allegedly not. I don't. It's
Shrove Tuesday, yeah.
Shrove Tuesday. But it says here in America they call it Mardi Gras or Fat Tuesday.
Yeah, Fat Tuesday. It's Mardi Gras.
But you still have pancakes.
No pancakes, just a lot of liquor.
Oh right, and it's on a Tuesday.
Well, it's called Fat Tuesday because you could eat meat on this day, and because we're going into a season called Lent for Catholics, where there's a lot of fasting, and so you could basically really feast tonight and do anything you want to do. But tomorrow you have to be a good Christian.
So you got your 40 days then, haven't you?
Yeah.
And it's probably our most Canadian day as well here, Dan, because it's when we actually crack out the maple syrup that's been in the cupboard for 364 days.
Okay. Yeah, we have a break on that one day. Let you guys have the rest of it.
It's also Carnival in other parts of the world.
Yes, yeah.
Most of my, I have 3 incredibly talented Python programmers that I work with, and they all live in Brazil. So they're celebrating, toasting the night away tonight.
Yeah, I work with a Brazilian, and she was sending photos of the Carnival. It looks great. Looks a bit more interesting than my pancake night. I was going to say as well at the beginning, I did joke about this, but this did actually happen, Dan, as I asked my wife. No, my wife said to me, what are you talking about in the podcast? And I said diffusers. And I said, what do you think is a diffuser? And she said, is it those smelly things? And I said, yeah.
We did have the idea to kind of play stupid that we didn't know what a diffuser was. So.
Yeah.
Well, just imagine starting a company selling diffusers in 1983 when no one, number one, didn't know why they needed it. Didn't know why it was so expensive.
What is this guy on about? It's just like.
But you definitely need one.
Yeah.
You definitely need
to
one.
make the room smell better. Yeah.
I can need more than one.
So the news article that we were going to talk about it's not really room acoustics related, but wireless earphones or earbuds as inexpensive hearing aids. There was an article we found around that they could be used as kind of a proxy to be used as hearing aids, because a lot of people use these and wear these things now, Apple AirPods, etc. And just wondering, because they're obviously a lot cheaper is one thing, but George was mentioning before about the potential, there's a stigma around hearing aids and what they look like. And I know they've improved a lot over the years. You don't have to carry like a big amplifier in your ear anymore, but it's definitely more discreet. I know, just something to kind of talk around and see. What did you think, George, about this?
Well, no, I thought it was really interesting because I went to a festival a few months ago, probably more than a few months ago. And there they had the University of Manchester there where you could, where they were giving out earbuds, but on the proviso that you filled in a questionnaire for them. And the questionnaire was before you use them, saying things like, will you use them? Where will you use them? Why will you use them? Do they feel okay? Blah, blah, blah. And then about a couple of months later, they sent you another questionnaire. And the questions were sort of like, have you used them? And, in what instances did you use them? And then there was a question about, give reasons why you didn't use them. And it was things like, the way they look, the way they feel, maintenance of them, things that you wouldn't necessarily think about. And I think also things like the social situations that you wear them in, situational factors, healthcare, all that sort of stuff. And actually, you mentioned before about using earbuds. Because they're so normal to people, like they wear them all the time. You can see how that would potentially be an option. Nobody would batter an eyelid to go, that looks unusual. And with young people, that can be a big factor for them. So I did think it was interesting. I wonder what the actual performance of them is like compared to.
Well, they'd said in the article that the AirPods that they tested, AirPods 2, were quite good at the kind of lateral, the ones that are in your immediate, like out from your ear. But when it came to the front, they weren't as good at recognizing that. But at least, because I think the cost, a premium hearing aid costs like $10,000, whereas AirPods, $2 or around $130. Like I guess it just makes things more accessible. I know you have like medical care and insurance and stuff that might cover some of this stuff, but I guess it's just rethinking that completely. And I don't know. Any thoughts, Peter?
2 issues. I mean, hearing aids. In fact, Trevor has a research project on hearing aids, but hearing aids are now available over the counter, so they've become a lot less expensive, a lot better in quality. The biggest problem was filtering the speech content from the noise. Not been involved in that research, but I work with a famous person in that field, Mead Killian, who did a lot of advanced research on the amplifiers that we use. I think because of the because of the smaller size, they become less of a social impediment. You're not carrying an amplifier behind your ear anymore in some cases. And also because of the fact that this generation is just using earbuds pervasively. I mean, you walk down the street, and if somebody doesn't have earbuds in their ear, it's an odd event. And the quality of the earbuds has dramatically improved. I mean, Apple now has spatial audio incorporated into their earbuds. So there's two systems at the moment. You have Dolby Atmos, obviously for listening environments with speakers, and Apple has a similar experience with earbuds called spatial audio. And the challenge right now for the recording studios is mixing content in that format. And Sony has a format. In fact, when I was down at the session at Blackbird Studios, looking to the front of the room, you had Dolby Atmos. If you turned around, you had another whole set of speakers for Sony's system. So that's a challenge I don't know if it's a challenge, but it's something that the recording industry is having to deal with to create content now. So a lot of these studios are basically remixing. George Massenberg said he was remixing a lot of content for Alicia Keys. We had a nice experience. We did her recording studios in New York with the WSDG. And so there's a lot of re-recording or remixing, I should say, to meet the surround sound format. I don't know that much about what Trevor is doing for his research on hearing aids. I'm sure it's good.
I wonder if, as well, people wearing earbuds is actually contributing to hearing damage for people as well. So it's
very possible, because you have, after a while, you don't realize how loud the sound is.
Yeah, especially when you can hear the music clearly from someone maybe on the train 4 or 5 seats down from you. It's like,
yeah, right.
Or the tube. For instance, people who I see on the tube in London listening to the earbuds, and I'm thinking, what are you listening to? Because if you can hear that, that's incredibly loud.
I mean,
that's really interesting.
I think it's possible to just put a governor on the earbuds, so they don't go above a certain level.
Yeah. I mean, they start to give warnings, especially on the phone. Once you get past a certain value, it says, past this point, you might be subject to hearing damage and stuff. I've seen that start to creep in, which is...
If you're turning it up that loud, you might be hard of hearing.
Yeah, but basically, well, I can't hear it, so I'm going to keep going. So. But it's interesting, yeah.
I personally can't. I've never been able to use devices in my ear canal. It just wasn't designed for earbuds.
Yeah, interesting article that they're looking into that and seeing if that's something they could do. But yeah, I know the cost of hearing aids has come down a lot. I have a couple of friends that work in the design of that. Yeah, it's just interesting. I think the visual stigma is definitely very real, I think, as we go down this line. And you never know, people might be younger with hearing loss down the line, potentially.
I think as well that there's already a bit of a crossover between the two. I know that my dad got hearing aids I don't know, a couple of years ago, and his ones, they connect to his phone, so they're pretty much the same as an earbud. He could be listening to stuff and then somebody's ringing him. He doesn't know what's happening. So it seems that there's already they're already seeing that, actually. And I bet I don't know if you can hear music, you can listen to music, and then you might be able to. But,
well, the original situation was headphones, and the big problem with the quality of the headphones continued to evolve. But the biggest problem initially is that the sound was in your head. It wasn't. Then they discovered a way to project the sound so you didn't feel like it was all in your head. I mean, there are some really good headphone listening environments.
Can you give us a demonstration here? Show us what they sound like.
It's one way to get rid of the room and put me out of business.
That was sort of one of the questions I was going to ask, but I thought I better not.
It is interesting, yeah, because I know I do mixing a little bit on headphones just to check because of that reason. People starting to consume it more in that environment, and I know that Waves do like a plugin called NX plugin, and it tries to simulate that real world feel of a loudspeaker system. It's not perfect. It kind of tries, but it adds a bit of reverb and kind of adjusts the phase a little bit. You can kind of hear. I don't think loudspeakers are going to go away anytime soon from the mixing environment at all. Like I think headphones you can tell when things have been mixed on headphones. You can still tell.
I might start a loudspeaker company if people are going to buy 16 of them for every room.
Yeah, exactly. So I guess before we go, Peter, like you obviously, I think, would recommend this field, but is there anything people that are thinking of getting into the industry, or any tidbits of advice of people kind of starting out as to what to expect and how to make the most of it, I guess?
Just by virtue of the fact, getting back to Salford, that Salford is building a new acoustics building. I mean, that's unheard of in my mind. There's, the world we live in continues to grow noisier and noisier by the day. So there's definitely an ever-evolving interest in noise control. So from that point of view, I think it could be a rewarding career if that's the direction that people want to go. And because music continues to evolve, there's going to continue to be more and more people like me that push the design of these rooms in even better directions. I think the one thing that I learned, if a company thinks that they are going to make a diffuser and grow that company by making, one or two diffusers, I think that's a fool's errand. You have to create a company that has a whole host of acoustic tools, as I used to call them, and there's always going to be need for it. I would encourage it. I mentor as much as I can. The number of schools that are teaching acoustics continues to either be the same or grow by one or two. I mean, I originally did my early research with friends in Europe because at the time, the exception of one or two universities in the States, there was much more research being done in Europe and Asia. And so I tended to collaborate with those people. Things have evolved more. There's really two types of, in my world, there's two types of acousticians. There's way more than two, but in the field of architectural acoustics. And that's the other beauty about the field of acoustics. You go to a meeting and you've got physical acoustics, music acoustics, underwater acoustics, you name it, there's a field for acoustics. But in terms of architectural acoustics, in my experience, you have two fields. You have academics who basically treat acoustics as a science, just like any other science. And then you have practitioners, people that carry out acoustic design, not doing research for the most part, but basically employing, sound acoustical principles to solve noise problems, solve acoustical issues of many other types. So there are those two areas to go into. If teaching or research is your interest, there are many universities that offer that opportunity, and there's a National Council of Acoustical Consultants, and there are any number of European organizations that I collaborate with that are growing. I think it's fair to say that pretty much every acoustical graduate can find a job.
Even Dan and me.
Yeah, no. Yeah. Well, thanks, Peter. Thanks for your time.
Okay, guys.
You're on the show, and appreciate all the insight you've given. It's great.
All right, stay in touch.
Really appreciate it. Great.
So thanks, everyone. Thanks for watching, and you can, of course, subscribe, comment below if you find this interesting and have any questions. You can reach out to us in the email in the description below. We have a podcast as well. So thanks to everyone that turns up and listens to me and George ramble and try and question some very competent people. But thanks, and hope to see you tune in next time. Thanks.